Unit 1, Part 4, Pythagorean Identity. The Pythagorean identity is sine squared plus cosine squared equals 1. In this case, it uses the value theta for its variable, so sine squared of theta plus cosine squared of theta equals 1. It just means that we're talking about the same angle here. You can't talk about two different angles. That's not going to work. If we're talking about the same angle, then sine squared of this angle plus cosine squared of the same angle is going to equal 1. So if sine of x is 3/4, what's cosine of x? Well, 3/4 squared plus cosine squared of x equals 1. So I just need to square this side. 3 squared is 9. 4 squared is 16. And then I need to subtract this value away from 1 because I need to get it away from my cosine squared. Well, 1 is the same as 16 over 16. So now I can subtract them. Remember, I'm taking this value away from both sides of the equation so that it cancels out over here, and it's now subtracted over here. So I guess we'll write 9/16 instead of 3/4 squared, same value. 3/4 squared is 9/16. We're subtracting it from both sides. It goes away over here, and we have to subtract it. If you're having trouble subtracting it from 1, think of 1 as 16/16. 16 over 16 minus 9 over 16 is equal to 7/16. So what we have here is, so cosine squared of x equals 7 over 16. We need to know what cosine of x is. So we need to take the square root of both sides. The square root of cosine squared x is just going to be the cosine of x. And I can't do something to one side of an equation without doing the same thing to the other side, because I would be leaving it an imbalanced equation. So, whoa, let's try that again. So I need to take the square root of both sides, not just one side. Square root of 7, I'm not entirely sure. We'll just write square root of 7 so we can have the most exact answer. We're not going to round it to a decimal. 16 is a perfect square though. Square root of 16 is 4. So our answer is cosine of x is the square root of 7 over 4. And you would have had to type that in here. So some of you wrote square root of 7 over 4, and that would have been fine. A lot of you also tried to put it in another way. I looked at all the ways that you put it in, and it should have come up as accurate if you had anything along the lines of the square root of 7 over 4. A lot of you forgot to take the square root of both sides, or you ended up with 7 over 16 and forgot to take the square root altogether. So be really careful. Number 2, you're doing the same thing, but now I have cosine and I'm looking for sine. Well, addition is a commutative property, which means I can switch the places of sine and cosine, and it really doesn't matter. It's not going to have any effect. So I'm really solving this bottom one in the exact same method that I solved the top one. Sine squared plus 4/5 squared is going to be equal to 1. So I need to subtract this from both sides of the equation and actually subtract it over here. 4 squared is 16. 5 squared is 25. So I subtracted 4/5 squared from here, and from here, because I need to keep my equation balanced, I need to subtract the same thing from both sides so that I don't affect my overall result in a bad way. So now I know that sine squared of x is equal to 1 minus 16 over 25. So 25 over 25 minus 16 over 25 is going to give us the answer to 1 minus 16 over 25. 25 minus 16 gives us 9. and when we subtract with fractions, they have to have a common denominator, and we keep that denominator the same for our answer. So 9 over 25. Now we have sine squared of x is 9 over 25. Looks like an A. Let's make it look like a 9. Now I need to find out what sine is. So if I have sine squared, I need to take the square root to get sine. If I do something to one side, I need to do it to both sides of my equation. So now I know that the sine of x is equal to the square root of 9 over 25. The square root of 9 is 3. It's a perfect square. And the square root of 25 is 5. So sine of x is 3 over 5, or 3/5. That one was pretty easy to put in. 3 over 5, or 3 over 5. I would have taken any answer that was remotely close to that and meant the same thing. Make sure that it means the same answer. So remember, sine squared plus cosine squared is equal to 1. And anytime you have sine, you can find cosine of the same angle. And vice versa, if you have cosine, you can always find sine of the same angle.